I'm going to do, and it's also a good problem, I have a beam of light coming and entering a prism. The prism is a 60-30 degree angle. Okay, I can draw the outline of the prism again. Okay, so then my question is going to be, when the beam of light comes out, at what angle is it going to come out with respect to its original direction? Right, so the original direction is horizontal like this. Like I can draw the original beam. Let's turn off the lights. So the original direction of the beam of light, let's draw that. What you can see, when the beams of light come out, they are going downward. So let's draw the downward direction. Okay, so now let's see if we can predict what this angle is. So first we'll measure it experimentally. Theta experimental, right? So let's measure that angle, 19 to 20 degrees, okay? So let's see what the calculations give us, what the theoretical, what that theoretical angle is going to be. So this one is a 60-30 angle, so this one is going to be the 60 degrees right here. Okay, so the beam of light is going to come in, right? And then first it's just going to go straight through, right? It's going to go straight through. Then what's going to happen when it comes out of the triangle right here, right? So we can draw the normal line like this. When it comes out of there, so what is this angle coming in? Right? So the initial angle with respect to the normal is going to be 90. Now what is this angle going to be? 30. Right, so if that's 30, this is also 90. That means what? This is 60. Right, so this and this are similar triangles, 60 and 60. That means this angle is 30. Right? So the angle coming in with respect to the normal line is going to be 30 degrees, right? So then you're going to have here n incidence sine of theta incident equal n refracted sine of theta refracted. So what is n incidence? Well, this n incidence, nothing happened. When the light beam came, it just went straight through because it came in similar to the normal line, right? But here, the incident medium is the glass itself, and then it's going to bend outward into the air. So the n incidence in now 1.52 is the n incidence, right? And then sine of theta incidence. So if this is going to be 60, this is 30. So that means theta incidence is 30. It's the angle with respect to the normal of the surface, right? So that's going to be 30. And then this is n air. The n refracted is n of the air. Then we have sine of theta r, right? So then we can multiply this. Okay, so what does that mean? So when this beam of light comes out, it should come out like this, right? It should bend outward from the normal, right? And this is the normal, and it should be 49.5 degrees from the normal to that surface, right? So that's what it means. Whenever we apply Snell's law, we're always measuring the angles with respect to the normal from the surface. So if this is 30, it's going to be bending outward from the normal, and that angle is going to be 49, whereas the original angle was 30, right? So it's bending outward, so it's working. But now our question was, what should be the angle from its original direction of motion, right? So if we superimpose here, the original direction of motion was horizontal, like this. What should this angle be? Okay, so then we can argue if this is 30, right? And then this is cutting it like this. So think of it like this. Right? If this is 30, this will also be 30. Right? These are alternate interior angles, right? 30 and 30. So if the whole thing, if this whole thing is 49.5, 49.5 minus 30 is going to be what? 19.5. So theta theoretical for this angle is going to be 19.5 degrees. Or I called it phi theoretical, which is going to be this missing piece down here, 19.5 degrees. This is perfect because when I did the experiment, I couldn't decide if it was between 19 and 20. So I could average it out, say 19.5 degrees, and my error will be 0% error, right? So you can do this with any kind of triangle. It doesn't have to be 60-30. You can get any triangle, 50, 40, 52, 38, whatever you want to get, and then have a beam of light come and then test the Snell's law and see if this is working. You could even have the beam of light coming at an angle itself like this, right? At some weird angle, and then find out what the final angle is going to be. So do all kinds of crazy good problems with that, have fun. So this is all an application of some geometry and also an application of Snell's law applied to the bending of light when it goes through a medium and then comes out of that medium. Okay? Thank you very much.